Okay, when you open the window for the molecules assignment, you should see something that looks like this. This is measuring infrared radiation. So you'll see the measurement across the bottom is the infrared wave number. So higher numbers are higher energy and lower numbers are lower energy. And then going from the bottom to the top is the intensity, which means how much of that radiation is absorbed. So if we just pick something like water, we can see it is absorbing way up high here, high energy, and we can see there's lots of little peaks that are medium intensity or somewhat low intensity. So the intensity goes from the top down. Something that is very high intensity will go all the way down to the bottom. And then we have some more absorption down here, and then kind of a broad range where there's less absorption. So as you click on the different molecules, you'll see different things coming up. One of the things that you're asked to do is to compare carbon dioxide and dinitrogen monoxide. So we have both of these on the screen right now. So let's just look at the molecules at the bottom. Here's carbon dioxide, and it's shown in a straight line or linear. And here's nitrogen dioxide. It's shown in a straight line as linear. So the graph, if you look up in the upper left-hand corner, this tells us this is the CO2 graph. And you can see it has a very strong peak. It goes all the way down to the bottom here between 2000 and 2500. And then it's got some other peaks here. So about 1, 2, 3, 4 peaks. Some of them are what we call doublets. They're sort of cut in half. This one is probably a triplet because it's got these little side wings on it. But basically about 4 peaks here, and some of them with really strong intensity. If I switch now to the dinitrogen monoxide, I can see I also have a very strong intensity in a similar area, but I have more peaks. So some of them are doublets, and some of them are much smaller, lower intensity, but I have more overall peaks. And we can put them on side by side here. You are also asked to look specifically at water. So what I want you to do is to notice how these peaks here have very clearly it's 2 peaks right next to each other, or a really big peak with maybe a couple of tiny things on the sides. But mostly it's 1 peak or 2 peaks. Now let's turn those off and turn back on the water, and you can see there's lots and lots of little narrow peaks, but all together they cover a much wider range. They're not as intense, but they cover a much broader range. And this is due to the hydrogen bonding, the fact that the water molecules are attracted to each other. And as they tug and pull on one another, they're going to change how that vibration works. Another thing to look at is all of the molecules that we call greenhouse gases together. So we'll turn back on carbon dioxide and dinitrogen monoxide, turn on our water, and we'll turn on our methane. And you can see with all of them, we've got most of that spectrum covered. There's a little bit of a gap in here between 3000 and 3500, and a little bit of a gap here around 1000. And in fact, if we take chlorofluorocarbons and click on that as well, we can see that some of those holes are covered in there as well. So even though no one greenhouse gas absorbs everywhere on the spectrum, all of them put together cover most of that spectrum. And that means that no matter what the wavelength is, unless it's some of these very specific narrow ranges, most infrared light is being absorbed by one greenhouse gas or another.